All right, our turn to draw esters. So remember, as soon as you see "08" in a name, it is absolutely guaranteed that you're talking about an ester and that there's going to be a carboxylate group in the middle of the thing. So you can draw this just instantly when you see that ending. And then it's just a question of how much carbon chain do you build around it. So in this first one, remember that we say the single bond oxygen part first and then the double bond thing second. So when they say methyl, that means on the single bonded oxygen we put a methyl group. And on the double bond oxygen, starting here, is where we build our pentanoate. Pent is 5, so this chain has to have 5 carbons in it. I put 1 carbon in just to hold this thing together. So now we need, there's 2, there's 3, there's 4, and there's 5. And finish this off. Add as much hydrogen as the thing can hold. That's a 3, 2, 2. This is a 2. And as usual, the carbon in the carboxylate is maxed out. It has 4 bonds already, so no room for any hydrogen. That is methyl pentanoate. Next one. Oh, look, 08. I guess it's beyond my skills to write a letter C. Let's try that again. Okay, it's an ester, so we have that for sure. Heptyl goes on the single bonded oxygen, and hept means 7. So 1 carbon, 2, 3, 4, 5, running out of space. Okay, there's a heptyl group. That was uncomfortably big. And methanoate means we have a single carbon on the double bond side, and it's already there. So all that remains to finish this one is to put in as much hydrogen as this can hold, and this carbon has 3 bonds committed, so it's got room for a single hydrogen. And that's it. Okay, butyl ethanoate. I see 08, so I know that... Oh wait, this is an ester. Ha ha ha. Okay, on the single bond we put a butyl group. Butane has 4 carbons, so 1, 2, 3, 4. And on the double bond side, we put ethanoate. Ethane is 2 carbons, so there. And then as much hydrogen as we can fit in. So that's a CH3, and this one has no room for hydrogen. Not too bad. A little bit repetitive once you know what you're doing. Propyl octanoate. Propyl comes from propane, 3 carbons. Because there's a lot of practice, and because I suspect you probably get the idea by now, I'm going to save myself a little bit of hand cramp and not do the hydrogens on these. I hope you will indulge me this spot of laziness, and on assignments and exams, please do include the hydrogens, but just so we can get through these a little more swiftly. Propyl group there, and octanoate means a chain of 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. 08 means it's an ester. Not surprising in the ester lesson. Ethyl goes on the single bond, so 2 carbons there. And on this side we get, okay, that's branches, we'll worry about that in a moment, butanoate. 4 carbons go in our primary. And then they say on the 3rd carbon, twice, put methyl groups. That's 1st, 2nd, 3rd carbon. And so we branch like so. Fair enough. Ethyl octanoate. We set up our carboxylate right away. We know we're going to need it. On the single bond oxygen, we put an ethyl group, that's 2 carbons. On the double bond side, we put octanoate, which is 8 carbons. Here's the first one, 2, 3, 4, 5. It's awkward writing right to left. There we go. Ethyl octanoate. And finally, the raspberry ester, 2-methylpropyl methanoate. What's going on with this? Are they going to make me look silly with the last problem? Okay. We have a propyl group on the single bond, which is 3 carbons. And that propyl group has a methyl group on its second carbon. Then, on the double bonded side, we have methanoate, which is a single carbon, and we'll do the hydrogens for this one just to wrap it up. We have room for 1 hydrogen there. This is double bonded, so 2 hydrogen spaces left. 3 bonds here, only room for 1 hydrogen. 1 bond there, room for 3. 1 bond there, room for 3. Whew. If that all made sense, you are ready to go out in the world and do ester stuff. If it didn't, please get hold of your instructor. We're usually around and always glad to help.